Alright, so what we're looking at is two sine waves. One's current in blue and one's voltage in yellow. Now what we can see here is they both line up over each other. Okay, so that means we have a phase angle of 0, or unity power factor. I'm going to show you what a capacitive load would look like by adding some phase angle. Okay, so what we can see now is we can see the voltage in yellow, current in blue, but the blue one is now in front of the yellow one. So we can say a capacitive load leads the voltage. Now we have an inductive load. So what you can see is you can see the current appearing first, then the voltage. So we can say the inductive load lags the voltage. Now we're demonstrating the power wave, and what you can see now is the power wave is completely across the horizontal line. So what would happen if you start to add phase angle? It starts to drop, and this little bit that's below the line, what actually that is the reactive energy that's being now consumed or generated by the load. As you keep adding phase angle, eventually you get to 90 degrees. Once you hit 90 degrees, all you have is reactive energy, and then the curve at the bottom equals the curve at the top, which that shows you that the energy is just constantly being traded, not consumed. If you keep going, adding more and more phase angle, eventually you get to the point where it's all below the line, and that means you're exporting power back to the grid, i.e. like solar.